things you could try. You might want to try to do this and see if that helps. This, you could turn that denominator into a monomial. I kind of like Monty's suggestion better. Just try to rationalize the whole thing and see what happens. What if I let u squared equal all of 1 plus x over 1 minus x? I have no idea if that will work, but it does eliminate that radical for me, doesn't it? So let's try that, because radicals screw me up. So what I'm doing here is making an approach based on knowledge of my limitations. And I got a lot of them. So one of them is radicals screw me up. Another one is minus signs. So help me do the derivative here. 2u du equals derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Remember, this is educated guesswork. And I really have no idea if this is going to work or not. Just what seemed easiest to me to try.
You just want to get rid of the rad.
Yeah, I hate radicals. I mean, unless we're talking politics. And then I love radicals. So now what?
Or minuses.
2. Got a 2 on top. I like that look. 1 minus x, that's a plus 1. 1 plus x, so the x's cancel. Now how do you like my substitution? The 2's cancel. I've got u, 1 minus x squared du equal dx. How do you like it? I don't like it too much. If you like it, I want to know why. I think it's easier to say why you don't like that. When I substitute for dx, I've got this 1 minus x squared in there. It needs to all be in terms of u. How do I get rid of the 1 minus x? I'm sure there's ways, but it's not going to be easy. So somebody tell me something else I could have tried. Well, rationalize the denominator. That's another good idea. Or notice that fraction inside the radical is an improper fraction. I could always try long division as well. So let's see what happens there. What I'm trying to do is go through techniques that we have said you should be paying attention to. So if I rewrite that, if I take x plus 1 and divide it by minus x plus 1, I'm going to multiply by 1 here. I get minus x plus 1. What happens? Oops, I'm going to multiply by minus 1. So that I get x minus 1. And what happens when I subtract? 2. So this changed this into the square root of 1 minus 1 over 1 minus x. That holds a bit more promise than what we did before. All right, now we could try letting 1 over 1 minus x equal t, or letting 1 minus x equal t, and I think that would eventually work. Question. I have not yet tried a suggestion that I've gotten, though, from a few people, which is to perform another, really an algebraic operation besides division that we should always be thinking of when we see radicals, and that's rationalizing them. So let's get rid of this. This one clearly did not help us. This one shows promise. We
Is that
might
your
be.
numerator too?
Pardon me?
Is that your numerator too?
Where did I get 1? Fortunately, that won't change things much, but thank you. Okay, so let's try, what was that suggestion somebody gave me?
Rationalize.
Rationalize the denominator. So how do I do that?
Multiply by square root of the whole thing. By x plus 1.
Well, I'd probably rationalize the denominator, not the numerator. So then you get the square root of 1 minus x squared over 1 minus x. Well, that looked very promising now, doesn't it? Now I see a trig substitution. I think I'm going to go with that. Well, let's see. If you did this here, if if you let t equal 1 minus x, I would say probably 2 over 1 minus x. Then what's dt?
-2 over 1 minus x squared.
Why will it end up being a positive 2 though?
Because it's a negative times a -1.
Yeah, when I do the derivative of this, right? Because this is 2 times 1 minus x to the -1. So this actually does show some promise, doesn't it? 1 minus x quantity squared dt, maybe 1/2 equals dx. But what's 1 minus x? Over t. So these are just the kind of things that you have to look at because you never know what's going to work and what isn't. I still think that's the best way, but I just wanted to show you the kind of stuff, you know, that you might possibly have to go through on a problem. So if we use this now, what will be our substitution? We're going to have the integral. Well, I guess I ought to go ahead and write this. That will be 1/2. This is now 2 over t squared. dt. So what would be our new integral if we're substituting here? Square root 1, very good. Minus, what an honor to be in your presence. And this is t. Let's see, then dx is all this junk. So that's a 4 on top, so 2 over t squared. dt. So it still doesn't look that great, right? But at least we got it into some kind of form. Now we could try to rationalize or something like that. So let's go back with this over here. This looks like the most promising of them all.
X equals 9.
Integral square root 1 plus x over 1 minus x dx. By pulling this trick, we are going to rewrite it as integral square root 1 minus x squared over 1 minus x dx. Okay, now what?
X equals 9.
Let's try that. Let's try x equal to sine theta. Then dx is cosine theta d theta. And we get integral square root 1 minus sine squared. Dx is cosine theta d theta. And in the denominator, we have 1 minus the sine. This one doesn't actually look very fun either, does it? Now tell me what to write.
Cosine
squared on top. 1 minus sine theta on bottom. Shoot, that's not going to do us any good, is it? I see it. I'm just waiting. See who else sees it. Actually, we're done now. We've got it. Cosine squared is 1 minus sine squared. Now wait! Slow down. I'm an old man. I got to do things slow, which sometimes comes in handy. Quiet you. Get your mind out of the gutter. So yes, the numerator is the difference of squares.
Don't you like have u equal cosine theta, and then du equals negative sine theta?
I don't know. But this is awful nice. Didn't this come out well?
Yeah.
So to me, there might have been an easy way to do this that I didn't see. But if I were to look, right, but I have cosine times cosine. No, you're not. So theta minus cosine theta. See, you guys are so used to me making mistakes. Plus an arbitrary constant, and then we have to back substitute. X is sine theta. So if you draw the triangle, that's x over 1 square root 1 minus x squared. So theta is the inverse sine x. Cosine theta is rad 1 minus x squared. So in creating your test, I do the integrals first. If I had grabbed this one, say, out of the homework to try and give you one that you'd already attempted, I would have tossed this. I would not have put this on the test. If that's really the only avenue to get to the answer, that's too long and hard a path. I wouldn't do that to you. I'd rather give you something that's a bit more straightforward. Because who the hell's going to think of doing that? Even if you do think of doing it, it might take you 20 or 30 minutes to come up with all that stuff. So I don't want that to happen to you. This one I think is, unless there was some real easy thing that I missed. Did anybody do this one? Find an easy way?
Yeah, I'm going with 1 plus x.
So you rationalize the numerator. Oh, and then you got,
Inverse sine.
that would have been the easy way. But still, I don't know. Yeah, watch what she did. This is the way to do it. It was an easy way. If you rationalize the numerator rather than the denominator, which is kind of totally against your training, isn't it?
Yeah.
All through algebra, they teach you rationalize the denominator, rationalize the denominator. And then in Calc 1, you see one lousy problem. Let's see, so 1 minus,
Oh,
wait a minute, I just did the same thing again.
1 plus.
Is that what you wanted to do? That's not what you wanted to do. Didn't you want to? Yeah, that way. Yeah, I see.
1 plus x squared on top.
Oh, wait a minute, that's what I wanted to do. I rationalized the numerator here, didn't I? Did someone tell me to do that, or did I do that on my own? Because of course, I would have done the training to rationalize the denominator. I don't know, maybe either I wrote that in a fit of stupidity, or somebody said it and I just did whatever they said. Then what do you get? Square root of 1 minus x squared? And then the trig substitute. You're still going to do a trig substitution. And that's still not going to be easy. So again, I think we'd toss this. Probably it's more than what I want you to suffer with. I want you to suffer, but not so much that you come hunting for me after class. Yeah, instead I just want you to go home and kick the kids and kiss the dog or something. Oh, wait a minute, I got that backwards. 45. Integral x to the 5th e to